All right, so we're going to start 3.3 today. 3.3 takes what we did in 3.2 by turning all of our raw data into a frequency distribution. So it's easier to look at, easier to kind of see what's going on with the numbers, and then tells us how we can find descriptors and statistics from a histogram or from a frequency distribution. So in 3.3, we're going to talk about how we find the median, the standard deviation, the mean, all of those kinds of descriptors we talked about in 3.1 and 3.2. But instead of being able to find it from a list of raw data, we're going to talk about how do we find it from a frequency distribution. The reason that that's a thing that we need to learn is because oftentimes in the real world, when you're doing research or you're trying to come up with information, you don't have the raw data. Someone else has collected the raw data and they've already compiled it and turned it into a frequency distribution. So you don't have all of the raw data. So you have to work with what you have. And so that's what we're going to talk about today. How do we work with what we have if we don't have the raw data? So the first thing we're going to talk about is how do we find the mean coming from a frequency distribution? And this is where we use that midpoint. So right here in our first example, we have a frequency distribution. We have our classes set up. We have the frequency of those classes, and we're going to use this information. We're going to find the mean of this data. In order to do that, we have to find the midpoint. So kind of going back to what we did in 3.2, how do we talk about the mean? Well, in order to talk about the midpoint, we have to find the average of consecutive lower limits. So 5.5 plus 10.5 divide that by 2, and we get our answer is 8. And so our first one is 8. We do that again, we get 13. Do that again, and we get 18. Now, the reason we are going to use a midpoint, or the reason we need to find the midpoint, is because we're going to use that as a representative value for every number that's in a class. So for this second class where it says we have a frequency of 2, so that means we have two numbers that are somewhere between 10.5 and 15.4. However, we have zero idea what those actual values are. They could both be 10.5, they could both be 15. We have no idea. So what we have to do is come up with a representative value for all of the numbers in a class, and that's what we use the midpoint for. So what I'm going to show you is kind of the easy way to find the mean using a frequency distribution. I'm going to start by showing you the long way. So essentially what we have here, once I found a midpoint, is I now can reconstruct my approximation of the raw data set. I don't have the actual data, but I can create a list of the possible values or representative values. So I have a frequency of 1, which means I have one value of 8. I have a frequency of 2 across from 13. That means my data set has 2 13s in it. And then the last one says my data set has 5 18s. So 5 18s. Now, if I wanted to find the average of that data set, now I have actual numbers. I can add them all up and then divide by how many there are. There are 8 numbers in this data set, so I could add them all up, divide by 8, and get my answer. However, because we have a midpoint, we don't have the actual raw data, we're going to have a lot of duplicate values. So instead of having to add 18 plus 18 plus 18, do that repeated addition, what's an easy way to do repeated addition? Multiplication. So when I'm going through and finding my mean, I'm going to do this step right here, which is frequency times midpoint. So I have 1 8, so it's a value of 1. I have two 13, so 2 times 13, 26. I have 5 18s. That gives me a value of 90. Then I'm going to add all of those values up. So 8 plus 26 plus 90, and that gives me 124. So I can either do this the nice shortcut way, which is the midpoint times the frequency and add those up, and I'll get 124. Or if I add up all 8 of these values, I get 124. So using the midpoint times frequency is just a shortcut. It's just an easier way of finding the numerator for our average calculation. So sum, and it's the sum of frequency times midpoint. So I'm going to do the frequency times the midpoint for each of my different classes. I'm going to add those all up. That gives me my numerator. And then my denominator is still how many things I added up, which would be my total frequency. So in this case, the sum of the midpoint times the frequency is 124. And then how many things did I add up? That's my total frequency. That's the 8. And then that gives me my average of 15.5. And that's how we can find the mean of a frequency distribution. Next, some more work along with these or around these frequency distributions. We talk about the modal class. Modal is the same thing as mode. So if we're finding the modal class, we're finding the class that has the most frequency or the highest frequency. So in this case, our modal class, so modal class with the highest frequency or largest frequency, our modal class is the 15.5 through 20.4. That has a frequency of 8, and so that is the class that has the highest frequency. This now walks you through how we can find these calculations using our calculator. And then it gives you that website. Also, YouTube is a great way of doing that. If you ever have any questions. So on an exam or a test, if you're asked to find the mean of something, so if you're asked to find the average, I will expect you to be able to show your work of how to find the mean by hand, whether that is from a raw data set or whether that is from a frequency distribution. I will expect you to be able to show me your work on how you did that, even if that's as simple as filling something out like this, where you're multiplying 1 times 8, and you're just showing me this much work here. But I need to see that work. I need to see what numbers are you adding together, what number are you dividing by. And so make sure that on a test or a quiz, you show me that work when you're finding the mean or the average of a data set or of a frequency distribution. However, you will not have to do standard deviation by hand. So using this same information, let's go through, let's use our calculator and show how we can find all of this information. So this is our same data set, so it has our same midpoints. Now, let's use our calculator. When we use our calculator, we're going to have to now create 2 lists because we have 2 different pieces of information that we need to store. So let's get back to our home screen. We're going to go to Stat, Edit. This is where our lists are. Again, the next thing we need to do is we need to clear out the list. This was used by us last. Now I need different numbers in there. So in order to clear that list, I'm going to scroll up so that L1 or the title of my list is highlighted, hit clear, then hit enter. Now, the two lists we are going to enter are going to be the frequencies and the midpoints. It does not matter which list you put where, you just need to remember them. I'm going to put my frequencies first, and I'm going to put my midpoints second. So my frequencies are 1, 2, and 5. And my midpoints are 8, 13, and 18. So essentially you can read this from list 1 and list 2 is I have 1 8, I have 2 13s, and I have 5 18s. Now we're going to take those two lists and we're going to plug them into that same place we went before. So second, quick, get back out of there, hit stat, and calc again. We are still only dealing with one variable. It's tempting to think of two variables because we have two lists, but those two lists are just describing one variable. We just have a frequency and a midpoint. It's still all talking about the same thing. So it's still one var stat, one variable statistics. The list is where we want to put our midpoints. So I put our midpoints into list 2. So I need to get rid of this list 1 here, and I'm going to put L2. This next one that has been blank when we were dealing with raw data, that is our frequency list. So it is the list where we put all of our frequencies. I put that into list 1. So make sure we get L1 there. It is important when you switch between your raw data and your frequency distribution. If you go back to raw data where you don't have a frequency list, you need to clear out that frequency list in this one var stat. That's a common mistake that people make is when they're going back and forth, they just did something that used a frequency list. So they were doing something with a frequency distribution, and then they go back to finding the average of raw data, but they forget to delete that list there, and it throws off their average. So we have our list in the correct space. We hit calculate. You can see we calculated our mean correctly. It is 15.5. And it also now gives us our standard deviation. And it gives us, again, both the sample and the population. This is a sample of data. And so our standard deviation is going to be 3.78. So S equals 3.78. X bar we already found was 15.5. If we needed to find the variance, we simply square our standard deviation. And we get something around 14.29. Now that standard or that variance will differ slightly depending on how far you rounded. When I wrote down the answer for standard deviation, I just rounded it 2 decimals, so 3.78. But when I squared it as 3.7796, which was a more accurate version. I went out to 4 decimals when I squared to find the variance. So if you only went to 2 decimals or if you went to 3 decimals, you'll get a slightly different answer on that. So if you did something different, that may be why we had slightly different answers. All right, so we've seen this data set before. This is our tax rate that we talked about in chapter 2. We are now going to do work with this frequency distribution. So find the midpoints for this whole list, and then we're going to find the mean and the standard deviation. Now, a question that will show up on a test and possible quiz, and the way the question is worded is extremely important. So one of the questions could be, find the mean of this data set. So if it says find the mean from the data set, so if we have from the data set or from the raw data, it wants us to use the actual values. If it says from the data set, if it says from the raw data, then it's talking about using the actual value. So we actually have to have all, in this case, 51 data points in order to do that. It could also say of the frequency distribution, of the grouped frequency distribution. If it says of the frequency distribution, then that means you use the data from the frequency distribution. So it could ask you both of those questions, and those two questions are going to be, or those two answers are going to be slightly different. You will get a different average if you use the actual data than you will if you use the frequency distribution. I know that, and that's okay. That's the point of, if you turn everything into a frequency distribution, it makes it much easier to understand the data, but you lose some of that fidelity. You don't have all of the data. And so now the statistics you're running off of, or you're calculating, are going to be slightly different than they would be if you kept using all of the raw data. Sometimes you don't have the raw data. Sometimes there's just too much raw data to look at. And so you need to use a frequency distribution just to kind of manage all of the data. So be careful when you're reading the question to understand where you're supposed to get your data and understand what it's actually asking. So those are two different things. From the data set or from the raw value, use the actual data. If it says from the frequency distribution, then use the frequency distribution. Even if we have the raw data, it wants us to calculate it using the frequency distribution. So we go through, we find all of our midpoints. Now, it says to find the mean first, and in order to find the mean, we have to show some of that work. Remember? So some of that work is going to be frequency times the midpoint. I'm going to fill out that last column that shows the frequency times the midpoint. Now, I'm going to do it in my calculator. So let me show you how we can not just plug numbers into it, but do more kind of simple math and make our lives easier using our lists. So we're going to go back to my handy dandy calculator. I'm going to go back to stat, edit, and again, I'm going to use list 1 and list 2. Clear these out. All right. So again, in list 1, I'm going to put my frequencies. So I'm going to put in the 7, the 14, the 7, all of those numbers into list 1. Looks like I have 9 different numbers entered. I'm going to go back and make sure I have 9 classes. Perfect. 9 classes. Next, I'm going to enter my 9 midpoints. So 0.25. All the way down. There we go. All right. Now I'm going to use these to find my standard deviation, but I can also do it to show kind of some intermediate steps. You can do math with lists while you're in here. So now that I have all of my numbers written, I don't need to see that. I'm going to go over to list 3. And in list 3, I want to multiply list 1 times list 2, because that's the work I need to show in order to get full credit on this question. So in order to do some math with lists, what I'm going to do is I'm going to go to the very top because I want to use every number in this list. So that's why I go to the very top. I'm entering a formula. It will then it'll use the formula with each row in these two lists. So I want to do list one, and see at the very bottom is where you're seeing that list. So list one times list two. And then when I hit enter, it's going to go down all of the data points I have in list one and multiply it by the data in list two. And there we go. So now I'm still showing my work. I'm still doing it by hand, but I'm getting a little help from my calculator to make it easier on myself. All right, so went into my calculator, found all of those values, and now I can add those all up. Now, I can add those all up, or I can add those all up by hand by plugging them back into my calculator, or I can go back and start using my calculator again to make my life easier. So again, back here. Now, based on my lists, the next step is I want to add up all of the things in list three. I want to sum list three. So I'm going to go back to my home screen. This time, instead of the stat menu, I'm going to go to second stat, which is list. And then I'm going to go to math. And in math, there's a bunch of different things you can do with lists. I can find the minimum value in the list or a maximum value in the list, a bunch of other stuff. You can find the mean, the median. Most of this stuff, mean, median, all of that, we do in our one var stats anyway, so we don't need to use this. The one thing that it's going to be helpful for is sum. So number 5. And I want to find the sum of list 3. So using that sum feature, it allows me to find the total if I had added all of that up by hand. And so I get 76, 75. I can go back here. Write out my formula. That gives me 76, 75 divided by, now I have to come up with the total frequency. So add up all of my frequencies. We can use our sum feature again, but instead of summing list 1, I want to sum my frequencies, which I put into list 1. And again, 51. We already knew that, but in case you didn't know that or you wanted to double check, you could do it that way. So we get the sum of the total frequency times midpoints divided by the total frequency. And when we do that calculation, we will get our average, our mean. So the average cigarette tax rate is 1.505%. Now, the next thing it asks us to find is the standard deviation and variance, and that we do using our one var stat. We can also check to make sure that we got our average correct. So when we come back here and we get into our one variable statistics and we do our list 2 and our list 1, when we hit calculate, that very first number is going to check to see, or it's going to show us if we calculated our average correct. If the number that we calculated and the X bar in our one variable statistics aren't the same, that means we did something wrong. You do not just get to write out the correct answer. If you just have the correct answer, you're not going to get the credit for the average. I need to see your work. So if you get a different answer, make sure you go back, figure out your mistake, and then change it. And then here we get our standard deviation as S is equal to 0.99 or 9918, depending on how far you went around. And then for our variance, we're going to square that, and I'm going to round out to 4 decimals when I square it. So 0.9918 squared, and that will give me my variance, which is 0.984 or 98, depending on how far we round out. All right, that is the end of 3.3, finding mean and standard deviation based off of a frequency distribution. If you guys are having any questions with your homework, anything like that, please make sure you're using that homework help or the help feature that's built into Pearson. Let me know. Have a good day.